Hey everyone, welcome back to Swift Fundamentals. Today we're going over properties in Swift, specifically stored, computed, and lazy properties. Properties help us store and access data within structs and classes, and each type of property has its own unique role. Let's go ahead and dive on in. So I'm going to create a new playground. Of course, if you want to add this to any of your existing projects, follow along, whatever works best for you. I'm going to create a new playground, and I'm just going to call it properties in Swift. Let's go ahead and delete the placeholders here. Go ahead and open up my console as well and set this to be automatically running. So let's go ahead and create our structure here. And for this example, maybe we'll use a car. This is actually the way I learned about structures in the first place. Someone taught me about a car factor, which is pretty cool. And we're going to add three different variables here. We're going to add the make, model, and year. So I'll go ahead and say variable make. This is going to be a string, variable model, variable model, and this is going to also be a string. And then we'll do the year, so variable year. This would be an integer instead, that whole number. So in this example, make, model, and year are stored properties. They store specific values for each car instance. Let's go ahead and create a car to kind of see them in action. So we're going to leave our structure and we'll say let car equals capital C car. We can even use the autofill feature here. So for this one, I'll say make Toyota, maybe model, I think Corolla is one. And then the year, let's put it to be 2023. And now let's print our car. So we'll say car dot make, and this should output Toyota. If we were to change this to be model, we can see that'd be the Corolla, and then year would be that integer. Stored properties directly store values, typically initialized when the instance is created, as we see here with Toyota. Now let's take a look at computed properties. Unlike stored properties, computed properties calculate a value each time they're accessed. So what we're going to do is we're going to go back to our structure of the car here. And we're going to make a new variable and we'll say full name. We're going to establish this to be a string. And then we're going to go ahead and add a brace here. And we're going to say return. Then we're going to add our quotations because we're going to be returning a string. And we're going to interpolate the year. We're then going to interpolate the make. And then finally, we're going to interpolate the model. So here, full name is a computed property. Instead of storing data directly, it calculates a value by combining make, model, and year. And let's see how this works with our car instance. So let's go ahead and now print car dot full name, and this should output 2023 Toyota Corolla. We can see in the console it absolutely does. So every time we access full name, it recalculates based on other properties. Computed properties are great for data derived from existing values. Computed properties can have getters and setters. This is useful when you want to control both reading and modifying a property. Let's make year adjustable through the age of the car. So let's go ahead and add a new variable in our struct here. I'm going to say var age, say that's going to be an integer. Let's add our brace again, and here we'll add our get. We'll add a brace again. We're going to say return 2024, which is the current year, minus year. Then outside of this brace, we're going to hit return, and we're going to say set new age. Add a brace here, lots of braces, I know. Then we're gonna have our year equals 2024 minus new age. So with age, we've added a get block to calculate the car's age and a set block to update year. Now we can read and adjust the car's age. So if we want to go ahead and say car.age equals 1, then we can now print our car.year. One thing we will have to change is on line 21, we actually have this be let car. Let's change this to be a variable so we can, make it mutate and things like that. With age, we can get or set values indirectly. Computed properties offer flexible ways to work with data derived from other properties. Finally, let's talk about lazy properties. A lazy property is only calculated or initialized the first time it's accessed, which is great for saving memory on properties that take time to create. So let's go ahead and create a lazy variable here. So what we're going to do is actually use the lazy keyword. So within our struct here, I'm going to create a lazy var, and we'll have this be called maybe car details, and we'll have this be a string, and then we're actually going to do equals space brace. I'm going to hit return here, and let's go ahead and print generating car details dot dot dot, and then we'll go ahead and return, and we can actually just go ahead and copy and paste from above here with our return statement here to save some time on our interpolation. I don't even know if that was faster. I'm pretty slow at copying and pasting. And then after this brace here, we can see that we have an error. Function produces expected type string. Did you mean to call it with brackets? So actually after this brace, we're going to add those brackets. So here, card details is a lazy property that only initializes when we first access it. This is ideal if generating card details takes time or requires resources. So let's go ahead and go down to our print statements down here, and let's actually print our car.car details. So say print car.car details. And we can see that has this print statement generating car details, 2023 Toyota Corolla. Okay, cool. So now we've used stored, computed, and lazy properties all in one. This combination lets us effectively handle and access data within our types. So that's it for today's lesson on properties in Swift. We covered the stored for direct data storage, computed properties for derived data, and lazy properties to save resources by deferring setup. Each type has a unique advantage, and depending on your use case, you'll want to choose which one to use. Thanks for watching Swift Fundamentals, and we'll see you next time. Take care.